Hi Sudhir. Hi Ravi. Good morning.
Hi Arul, good morning. How
How
was
are
your
you?
weekend?
Yeah, actually, I went to Madurai actually for one work, and then again I came back like this. Uh,
Okay.
How was your weekend, Ravi? Everything well?
Yeah, it was good. Yeah.
Okay. So today is our last class, and are you able to follow all the things? Like, did you try something, Ravi, Sudhir?
Yes, sir. Maybe I'm good actually. I got whatever required, but practice, yes, that is a continuous thing, right? Yeah.
Yeah. Please do, and Sudhir, so that you will keep proficient. You will get yourself proficient on these things.
Yeah, yes, Arul. Me also, I tried to understand about this rag and all.
Yeah,
So,
try
like
this, Ravi,
general,
because RAG is very,
yeah,
very important concept. Yeah.
yeah.
Yeah, Ravi, you're saying something.
So about rag only, so it is like it will give you accurate data, right? Like for example, in ChatGPT also we are using rag, right? I mean, companies
Uh,
are using.
yeah, they will be using GPT-4 as their model and they will try to access that. So the thing is like the LLM behind is taking care of restructuring the prompt and the question. Like the answer
Right.
itself is not generated from there, right? So accuracy standpoint that depends on the vector database and the techniques what we are following. Like we have seen about RAG, right? There is another concept called graph RAG. So
Okay.
that graph RAG came into market on some 2 3 months back only. That's from Microsoft. Okay.
Okay.
So that is very, very good in the sense like it is taking the contextual information correctly. Means that suppose in case in the first line I am saying like Arul is a person who is working in so and so, and then after some 7 8 lines back, and then I am referencing Arul as he. Okay. So that
Okay.
point, your regular similarity such as whatever cosine similarity, whatever we are using, right? So at that point, it cannot understand the first sentence and the third sentence likewise, right? So the third sentence also I am referring Arul only, right? So that kind of capability the regular RAG will not do. So for that, actually, Microsoft came up with a good idea called Graph RAG. So that is trying to find out the relationships wherever we are referencing the previous personalities likewise. So those things and all it is doing, and it is doing the contextualization. So, like accuracy is the main picture here in RAG because we are not digging that information from the LLM because LLM is having transformers and all these architectures behind. So it can easily take out that information correctly. But bringing that information from these vector databases, that is a challenge actually. For that only, like no daily we are getting one RAG techniques like. So with that
Okay.
track techniques alone, it is evolving only, Ravi.
Okay. Yeah. Because yesterday we saw in the example, right? We tried for that, say like APCM and all, but it's not giving accurate data. So I thought maybe either it is using or not in ChatGPT, this
No,
that
no, no.
concept.
Yeah. Like actually, the thing is like the accuracy depends on like how our data is relatable to each and every context. So the sentences should be clearly defined. See, I gave my resume, right? So I might have referenced myself as he or something like that. Then that will not be easily uh, findable in the similarity set itself. So the retrieval part is very, very important. Right? So if the retrieval is correct, then after that, anyway, end only we are going to the LLM. So in the retrieval part itself, if it is doing properly, like if it is taking out all the relevant information related to the question, then you will get an accurate response. If the retrieval part itself is like very slow and you are not able to get the context out of it, then that RAG won't work like this. So whatever we saw is called as baseline RAG. So that is the very basic version of RAG. So on top of it, nowadays, like lot of RAGs are coming in the market, and RAG alone is a big area because RAG is what companies are doing. They are doing only RAGs. They don't do fine tuning, and they don't do any new LLMs, right? So they are always chasing for this RAG techniques only. And that's why daily one new techniques are coming into the market.
Okay.
Yeah. Suppose what I'm trying to say is, let me share. Okay, if I have a context like this, okay, like Arul is so and so person, like this I am doing, okay, and then after some point, at some point, I am referencing someone named Yesra, like this, okay, and then at my third or fourth sentence, if I am referencing he, like this, right? So now my document is like this, okay. If it is like this, then human can understand. Now I am representing Yesra. Correct? If I am reading this as a novel, okay, in the first line I am taking like Carol is something like that, and in the sixth or seventh line I am taking like Ezra is something like that, and on the 10th line I am saying that he is likewise. I am referencing he with Ezra, right here. If a person is reading this as a book, then he can easily understand this. So this particular context will be missed in RAG. Why? Because this he it cannot understand to whom it is referencing. Right. So this particular information will be missed off. So to overcome this, Microsoft came up with a relationship idea so that it can easily do a relationship between this context. So for that only they came up with an idea called graph RAG. Okay. Graph RAG. Okay, so this is called as graph RAG. So what this graph RAG is doing, it is trying to find out the relationships between the text. See, each circle is an entity, a person, place, organization. See, likewise only it will do. Like every RAG is having different techniques, but Microsoft's RAG is like this is the biggest RAG so far. Like but it will take so much of time to prepare the vector database itself from this. See, they are having something called the graph RAG, right? So this graph RAG is from Microsoft. This technique is from Microsoft, I guess. You can see some notebooks also, but this will run on Azure cloud because this will take so much of time to prepare that data and its relationship itself. That's why they are running it in cloud actually, like this. Okay. This is how RAG is evolving, and RAG is one such useful technique. Like you can go here and see like recent RAG development. Like this, yeah, these are like top 5 trends, right? Like this, daily you can find lot of information on RAG. So everyone is running behind refining this technique. You see this one, lot of approaches, self-RAG, re-ranking, flare, like these things and all are coming in the market. See, daily you can find some papers on this area. So try exploring RAG more so that we will come to a picture on how this industrial RAG works, right? So in this episode, we told like this is how an entire industrial RAG looks like. Okay, the techniques might change. Means that the embedding, chunking, and vector database, right? So this CD, so B to C and C to D, right? So these techniques will change. But the thing is like this this terminologies won't change. Chunking will be always chunking. Embedding will be always embedding only. Vector database will be always vector database only. But the method how they are chunking and the method how they are embedding, right? So that changes from rack to rack. But anyway, end of the day, this is the complete rack. So with this, if you are able to understand this map, then you can easily grasp like how a rag is working. That's it. With that, everyone is having some different concepts, as I told you. Right, Ravi, you got some clarity?
Yeah, yes, sir. Yeah, it's clear. Yeah.
Yeah. Please explore these rag techniques as and when you are hearing about something. Also, like try doing this exercise in our notebook itself, like whatever we have done on the last class, right? So you can try installing Langchain and all these things. Like you can use Langchain, sentence transformers, Pies is our vector DB, right? So in today's class, we will see something about Chroma DB. Chroma DB is also a vector data. Okay, and then Hugging Face embeddings we used, right? So embeddings, just try to correlate this one with this image, this flowchart. Okay, so this flowchart will tell you how RAG is working. This alone is sufficient for you to understand how RAG is working. Okay, considering in this way, let's. So far we have covered up to day 15, right? So today's class is all about building real AI projects. Anyway, we will talk more on today. Now we talked about RAG and all, right? Like what the industry is doing, right? And then we will talk about this, how this open source is evolving in AI, right? We will talk about Llama 3.1 models, and then we will talk about this Langchain. Langchain we have already used here, right? So this one we will talk in a bit brief. We'll discuss a bit brief about this Langchain. Langchain is an LLM framework. I told on yesterday's class, last class, saying that we will see deeper on tomorrow's class, right? So Langchain. And then there is one more framework called LlamaIndex, and where we will be using this LlamaIndex. And we will do a practical exercise to build a RAG-based question answering system from a web page. Okay, we will feed a web page, and on top of that, we will do question and answering. Okay, so in that web page, if we are asking any questions, then it can answer likewise. So likewise, we will build one more RAG system. Okay, anyway, RAG is like RAG only we are doing all the exercises mostly, right? Because that is the one which is very important in the industry. And then that's all for today's class. And yeah, and then we will connect together in our group chats, WhatsApp, right? So you can reach out to me anytime. And yeah, this is the notebook. So I will be sharing this notebook with you. So this is going to be the notebook. Okay. And all the notebooks are present in this GitHub. So go here, you can go to this Python and Gemini. Okay. In this, you can find whatever we have discussed, like all our class notebooks will be present. Here you can make use of this. These and all are our class notes. And you have our recording playlist, right? So that's where we are uploading all our records. So anyway, I shared it in the group. Again, I will share it by email. Okay. So this in today's class, let's discuss deeper about this Langchain and LlamaIndex. Okay, Langchain. Why we are having Langchain and LlamaIndex is like these are like frameworks for the existing AI stuffs, like existing LLMs, and if you want to access any LLM, right? So for that, there should be a framework to access. Framework is nothing but it's like a kind of a package, you can imagine. Okay, so what our package will do, our package will contain lot of modules, and inside that modules there will be some built-in functions, right? Same like this framework will have multiple modules and multiple functions that will give us the ability to communicate with the LLMs, so that we will get out the most out of things, most things out of the LLM like this. So for that, these frameworks will give us the capability, and Langchain is one such kind. Okay, you can use Langchain by doing a pip install itself, and or else you can go to Langchain and see what it is telling. See here itself, they are telling like application that are that can reason powered by Langchain. Like, okay, means that like you can build some products on top of LLM using Langchain. This will be giving you the capability to build the AI related tools very fastly. Okay, so Langchain is used to build, run, manage, right? So here, instead of having for RAG itself, Langchain will help you to simplify the things. That's why in yesterday's class also we used Langchain, right? So if you see here, see, we have used Langchain document loaders, text splitter, embeddings, vector stores, and chain, right? So these and all are the modules of Langchain. Okay. So inside that module, again, these and all are the packages of Langchain, and inside that there will be some, this is a module. Okay. So this PyPDF loader, character text splitter, right? Hugging Face embeddings. Hugging Face embeddings we are using from Hugging Face, but that we are accessing it through Langchain, so that this package will help me to easily access this model likewise. So why we are using that? Because like instead of writing so much of code, we will be utilizing the existing built-in function, right? So with that built-in function, that will be helping us to easily access these tools, which can be easily accessible from an LLM standpoint. So instead of writing our own code to access these LLMs, that is also possible. That support also was provided by most of the LLM providers, like this OpenAI, Gemini, Claude. All these people are having some different set of libraries, right? So to access everything at a single point of place, we use Langchain as the framework. And using that Langchain, we can do multi-model stuffs also. You can use one or two models also inside the same program itself. Okay, I can use ChatGPT, I can use Gemini, right? Everything at a single program you can use by using this Langchain package. So inside that Langchain, inside that there will be a lot of modules, and inside that there will be a lot of functions. So those will be giving you the ability to communicate with the LLMs very fastly. Okay. So for that particular purpose only, we have this Langchain, the same kind of stuff only LlamaIndex, but LlamaIndex is something different. LlamaIndex, we will be using it for document retrieval and all this. Okay, so these two are the trending frameworks which are present in the LLM space, and these frameworks will be used to do the chaining in the sense like you can do multiple prompts easily like this. Okay, so this is the website for Langchain, and same way we have something called LlamaIndex. Yeah. Okay, if you go here, this is a data framework for production ready LLM applications. The term itself is saying this is for index, so means that this is used mainly for building indexes on top of RAG systems. Okay, so it will be helping us to build the indexes on data whatever we are using. Okay, so for that particular purpose, see, it is loading the data, it is helpful for loading the data, it is helpful for indexing, and it is helpful for querying and evaluation. Okay, so this is the purpose for LlamaIndex. Okay, so this is one framework, and Langchain is also one framework. So this you will use with JavaScript along with Python. TypeScript is nothing but the refined JavaScript. Okay, this is built on top of JavaScript. And Python is like our own Python, like what we have used, right? So for installing that, you can use this pip install command. And lot of connectors. Connectors means what? Like connectors means like you can integrate it with any LLM, any large language model. Okay, so this is for playing with the data. Okay, and this is for using everything, like this is for building applications on top of LLMs like this. So yesterday what we did, yesterday we used this PyPDF loader, character text splitter. So these tools and all are part of this Langchain. Means that if we access this, then we don't need to code everything which is present in there, right? So we can simply use this PyPDF loader. So that what it did, it simply load this PDF file and it convert that PDF file into a text, right? So that conversion is happening within this function itself. Okay, those kind of ability this Langchain is giving for us. That's why we are calling it as a framework. Okay, Langchain is a framework, and LlamaIndex is also one framework. Okay, this is for data, and this is for building applications. Okay. So the same thing, whatever we have discussed now, that is present in this document. Please go through this text format so that you can easily understand. Okay. And here in this document itself, I have briefly pasted this content for what is LlamaIndex and what is Langchain, so that you can easily go through this and you can understand. Okay. Whatever we have discussed this here in this class, that one only will be present in this document. Okay, let's do a demo. Okay, still now we didn't use this Google Gemini, right? We didn't use the Google Gemini API. In last class, what we did, we simply used this RAG by downloading this Llama 3.1. That's an open source model, right? So we downloaded Llama 3.1 and we ran it inside this Google Colab itself, right? And using that Llama 3.1 only, we were doing the RAG, right? Instead of that, today also we are going to do one more RAG. And in this RAG, we will be using this LlamaIndex, right? Because yesterday we used Langchain already. Okay, for Langchain, you can utilize this one. You can use this program to understand Langchain. The same way here we have LlamaIndex, right? So in our current project, whatever we are doing today right now, that we will be utilizing LlamaIndex, and we will be using something called ChromaDB. Okay, ChromaDB is nothing but like there we used FAIS, right? FAISS. FAIS is what? So Facebook AI similarity search. This is a vector database, right? So this will be useful to store the numerical representation of data, that is vectors. So those vectors will be stored in this FAIS. So thus that FAIS is having the ability to store the vector in the local storage itself. The same way we have something called Chroma. Chroma also can store the embeddings locally inside our folder itself. Okay. So this is what we are going to do now. And for the LLM part, we will be using Google Gemini. Okay. And in Gemini, we need to get the API key. Okay. So for that, what we can do, first you need to access Gemini. Okay. This LLM is not going to run inside your machine. That will be running on the cloud. Okay. To access that particular LLM, which is running on the cloud, for that particular purpose, we need an API key. Right? API key is nothing but like your physical key to open the door, right? Same way, if you want to access something from the cloud, you need an API key. Then only it can authenticate that, okay, Arul is going to do some operations on the cloud likewise. Okay, to that identification purpose only. And why we are using Gemini is obviously this is free, right? So this is free to use up to certain limits. So what we can do to get an API key, just go to this aistudio.google.com, right? After that, you will be asked to sign in to Google. Once you sign into Google, you will be seeing a window like this. Okay, here click on Get API Key. When you click on it, what happens? It will go to this particular window. Okay, so you can create unlimited number of API keys. Okay, not an issue. And that particular API key, you can use it in your project. And once you complete using it, please try to delete this. Okay. See, yesterday I created one API key, right? I can delete it. Likewise, if I am not using that API key, please try to delete it. Okay. So what I need to do is I need to click on Create API key, and it will ask me to create a cloud project. Okay. So the very first time when you are coming here, it will ask for a cloud project. You can select any cloud project you want. Okay. Or else there will be some default project also. You can select that as well. Okay. And then what you need to do, you need to click on Create API key in existing project. Like this. Okay. Once you do that, it will be giving you an API key like this. Okay. After that, copy this API key. Now I did a copy, right? Or else I can just go to any API key and click on it, so that it will show me the API key. This is my API key for this particular project. I can copy this. Okay. Then I need to come to my notebook. So in my notebook, we have already seen what these things are. One is table of contents, one is for searching. This one we used for finding that variables, right? This one we used for uploading and downloading files. Same way we have something called secrets. Okay, using that secrets, you can store your API keys. Okay, so what we need to do is we need to store our API key here like this. See, now my API key is this one, right? So I can do like that, and I need to give a name for my API key. So with this name, I can directly access it from my Google Colab notebook. See, here it is saying that, right? You can use like Google Colab, import user data. And in this user data, if you are giving this name, then you can get this value request. So this is like a kind of a private dictionary. Okay, this cannot be shared. Now I shared my notebook, right? But there you cannot see this API key. That's what here they are telling. The values stored here are private, even though I am sharing my notebooks like this. Okay, you cannot see my API key. Okay, so Google API key. Likewise, I'm storing this. Okay, I'm just deleting this, the existing. So I need to save it like Google underscore API underscore key. This might be any name, whatever you want. Okay. So if I do that and if I enable it, okay, then only this key can be accessed inside my notebook. Okay. So now I have this value. This is the key which I copied from here, right? And then the same way I named this key as Google API key. I can put any name, whatever I want. Okay. Why I am putting Google API key? Because inside this program, I am accessing it in the name of Google API key. Okay. So this is how you can use this. Yeah. And if you are giving notebook access, this can be accessible across this notebook, only inside this particular notebook. Okay. And then I need to close this. So now I set my API key so that I can access Google's Gemini AI using this API with the help of this API key. Okay. Now I have my secret stored. So after that, here we have, yeah, as I told you, we are going to use Gemini, LlamaIndex, and Chroma to store all these open source embedding databases. Okay. So here I'm just opening my files. There is nothing, right? I already have this existing sample data only. And then now the very first thing we need to install all the dependencies which are needed for executing this RAG. Okay. So for that particular purpose, we are going to download LlamaIndex, because with LlamaIndex only we are going to demonstrate, right? So for that particular purpose, we are going to install LlamaIndex and ChromaDB. This is going to be my vector databases. Okay. So here we are going to use embedding model also with Gemini only. There we used embedding model as Hugging Face, right? So instead of Hugging Face, we will be using embedding also Gemini and LLM also, that large language model also Gemini. Okay. So both the things we will be using Gemini, and then we will be using something called the readers web. So this will be helpful for us to read the web page and store it in ChromaDB. Okay. So now if I am executing this, okay, now it gets connected. And now it is trying to download and install my LlamaIndex stuff first. Okay. So here it is trying to download and install Google Gemini. See, this green cursor is moving, right? Accordingly only it is installing. Okay, in that particular order only it will install. So we are not going to install Langchain here. See, we didn't use Langchain because Langchain we already used in this particular example. Okay, the same way here we are going to use this LlamaIndex. Just ignore this because this is already there. That's why. Okay, so it's trying to install each and every from the LlamaIndex to this file system. What's this? Okay, LlamaIndex is a bit of a big package only. That's why it is taking so much of. Okay, otherwise I could have run it in GPU as well. But anyway, for this particular thing, we are not going to run the model locally, right? So we don't need to waste the GPU. Okay. So now this has been installed. That's why we get a green tick mark here. Okay, and after that, here we are configuring our API key. So for that, we are going to use this OS, means that the operating system package itself. So in this, the entire environment means that this is running on the Linux, right? So this particular notebook is running on the Linux environment in Google Colab, right? So there and all, wherever I am using API key, that needs to be used with this particular value. Okay, this particular value. Right. So for that, what we are trying to do is we are getting this Google Colab user data that is here only. See this particular 2 lines of code, right? The same 2 lines of code here also we are using. See. So if we are doing that, that value can be stored in this particular Google API key. See, if we are giving this secret name, this is the secret name. This is Google API key. So that one we are taking out and we are storing it to our local variable for this node, right? So this particular local variable now will have this value. So whatever value we are feeding here. Okay, so that key, it is taking it from here and it is storing here. Or you can print and see. I don't know like whether it will allow me to print the keys or not. See, it's printing my key, right? So you can double check your key here also, like whether this is correct or what. Like see the same key only it is printed here, right? So see here simple. We are just setting this key in the environment variable. Okay. And then so here we are going to as like in RAG. Okay. So in RAG, what we need to have a retriever as well as we need to have a generator. Okay. So retriever will be helpful for retrieving the contextual information from the document, and generator will be helpful for generating the information like this. Okay. The same like our this particular diagram only. Okay, retrieval augmented generation means that when you are querying something, it is going to retrieve something from this database and it will augment this response, right? Means that this one along with this one, the data it retrieved, along with that, it will do some ranking and that one it will feed it to the LLM. And this LLM will, what it will do? It will simply format whatever inputs come here to the user in a natural readable form. That's what it will do. Okay. The same thing we are going to do here as well. Okay. So for that, we need to get the information. So our main purpose of doing this LlamaIndex exercise is to read a web page, and on top of that web page, we are going to ask any questions, whatever we want. Okay. So here, what we are trying to do, we are going to import the required libraries. So these libraries are important for our operations. Okay. So libraries means what? These and all are our packages which we install. So those packages we are importing here. Okay. So this BS4, this is for beautiful soap. Okay. Beautiful soap is nothing but this is one web scraping stuff. Why? Because we are going to scrap a web page and store it in this LlamaIndex. Store it with the help of LlamaIndex in the Chroma vector database. Okay. So for that particular purpose, what we are going to do is we are going to use this beautiful soap and this markdown display, right? So with that help, with that we can again extract it in depth on top of this one, right? So we can scrap the web page with beautiful soap, and we will be using IPython package, and then we will be using this llama indexes, right? So there alone we will be using document settings, simple directory reader, storage context, vector store index, right? So these and all are the packages which are important when you need to do a RAG processing with this llama index. Okay. And then we have something called a simple web page reader as well. We will see each and everything down there. Okay. And then we will be using this Chroma vector store as well. So this is also part of this LlamaIndex package itself, because this is a framework, and and under this framework, it will be helping you to store it in the ChromaDB. Okay. And ChromaDB, as usual, this is going to be our vector database. Likewise, here we use this FIS. This database will be FIS here, right? So instead of that, we will be using this ChromaDB. Okay. ChromaDB we will be using, and this is called as regular expression. Regular expression is to clean the data. Okay. So this imports I am running. So it's nothing. It is just importing all the packages here inside this notebook, so that we can use these packages across this notebook. So okay. So the very first part, we are going to read and parse the data. Okay. So for our example purpose, what I did was, like, there is something called VO. Okay, so this VO is nothing but this is the recent research with Google DeepMind. Okay, so this is also a video generation model. This is also related to GenAI. Okay, like how surreal the videos are looking like, right? So everything was created by artificial intelligence. Nothing is a camera shot videos. Okay, see the building, see the dog, everything is so real, right? So these things and all were created by this Google DeepMind. So that technology is called VO. Okay, so this is the model for that. Yeah, I didn't try it so far, but I was just reading through this. So I just want to summarize everything and what it is capable of, right? And who are all the contributors for this project, right? So this particular web page is having this particular one page itself, the single page itself is having lot of information, and it contains video also. But inside that, I need to dig deeper on this text, and I need to see what exactly this is, right? So this is my purpose. So for that particular purpose, what I am trying to do is I am trying to fetch this link and read this complete HTML of this web page. And out of that, I will directly scrap whatever text information it is having into my Chroma database. That is going to be my vector. And on top of vector, whenever I am requesting something, we are going to do a search. And with that search, we will be responding back to the user. Okay. In the real world example, how this will be useful? When you are building a chatbot, right, for your particular company, right? So you need to have an FAQ kind of document, right? So that might be available somewhere in any web pages like that. Okay. So that web page, you can use it to pass here instead of this particular web page. Like now how we are using this DeepMind, right? So the same way you can pass your company's FAQ documents here so that your chatbot will become a FAQ master, right? With the help of this ChromaDB kind of vector databases. So that that particular data will not be used for getting trained for LLM. Okay. So if I run this, what happens? It is converting, it is scraping this web page, right? It is scraping means what? Like it is trying to load this web page using this beautiful soap. So beautiful soap, we are not directly using that. That beautiful soap is built in inside this simple web page reader. So this simple web page reader is part of this LlamaIndex. Okay. So this LlamaIndex, see inside this, if you see, this is the backend. Okay. So inside that, so this is the module behind the simple web page reader function. Okay. So that is trying to convert this HTML page into a text like this. Okay, so for that, what it did, it just simply take out this document, and in that document, like it will simply load the data, and that data we are converting it into text like this. So now we have this complete information, like the complete web page information as a HTML like this. See, it just scraped the complete HTML. What is this one? This is nothing but if you do a right click and inspect, right? Here you can see the sources, right? Here you can see these elements, right? So here itself you are seeing the complete HTML, right? So this particular web page is rendered with the help of this HTML only, right? It is nothing but a HTML which is displaying here. So that HTML, it is scrapping it in this form. So this also we use this LlamaIndex library called simple web page loader. See, simple web page reader. So this reader is capable of reading this particular web page, and it will simply pass me this HTML. Okay. So again, here only we will be using beautiful soap. Beautiful soap is used to parse this HTML. Yeah. Parse means what? Parsing means it can simply go through that document, this HTML, tag by tag, and it can simply read out the data whatever we want. Okay. So for that we need to parse this HTML. So for that we will be using this beautiful soap library to parse the data. Okay. So there what we are doing. So now my soap will be converted it into a beautiful soap object. And inside that I am using a function called find all, and I am finding all the paragraph tags P like this. See, here you can see P like this. It is not a completely expanded HTML. Okay. So if I go to the sources, I can see like we open this HTML page somewhere that HTML page should be there. This is the actual HTML page, right? So here, if you see, if I expand everything, okay, there will be some paragraph tags. There only this particular text is getting written. Okay. So to get that, we will be using this command. We will be using this function to find all the paragraph tags from this HTML code. So once we do that, every paragraph tag, okay, we will be adding the text value into this text content. Okay. So now everything will be converted it into the form of a document. Okay. So now if you print this documents, right? See, now it is converted. See, these and all are the text there. Okay, the text is having latest post, latest technology post. See, it generates high quality 1080p resolution videos that can go beyond a minute in a wide range of cinematic and visual styles. So this is nothing but this one. See, this information, right? So this is getting captured here now, right? So now we scrapped this web page and we have extracted the text content out of it using this beautiful soap, LlamaIndex, right? LlamaIndex, this simple web page reader. This one read this web page, and with that web page, we have extracted all the paragraph tags using this beautiful soap. And out of that paragraph tags, whatever content is there, those content we are just taking it out and we store it in the form of documents. Okay. So now my documents will have this. And then now what we need to do, now I have a text here, right? Now I have a data here. So this particular data, this text, I need to embed. Embed means I need to convert this into vectors, right? So when I do that, right? So now I have just what we did. We will be using this embedding model from Google Gemini. Okay. So we are just loading that model. And here, which model we are going to use for embedding is this one, Gemini 1.5 Flash latest. So using this particular model, we are going to embed this document, this particular information. Okay. Now it is setting up this LLM, and here what we are going to do is we are going to use this Chroma DB, and inside that Chroma DB, we are going to create a collection called quick start. This is going to be the collection. Okay. Collection is nothing but this will be having lot of documents. Okay. So inside that collection, we will be doing the vector embeddings, and we will be storing it in the vector store like this. Okay. See here, it is trying to create an index from the documents and save it to the disk. See, if I run this, what happens? It is trying to create an index, and see here, it just saved everything in ChromaDB. This new folder, same like how we saw in FiceDB, right? Same way, this is the embeddings. See here, these and all are the binary formats representation of the data, right? So we cannot see it in the plain sight. Okay, so this data might be an embedding one. Okay, embedded data. So this is like the vector stuff. Okay, so the vectorized data is present here. Right, so now my embeddings are ready and my vector store is ready. This is my vector store, right? So in our RAG also you can see data. This is our web page. That web page got chunked into embeddings, and those embeddings, this means the numerical representation, that one got stored in the vector database now up to this point. So you have created a vector database now, right? So inside that vector database, you need to, as usual, as we see here, we did a retriever. We built a retriever. You remember, like I told you, like if retriever is nothing but it's like a library assistant. So this library assistant is built on top of that, so that you can directly go and fetch whatever information you want based on the questions which got asked. Okay. So for that particular purpose, we are building a retriever and we are testing it. See, this retriever is working fine or what, like this. The term itself is saying this is a retriever. So here you can ask any questions. That questions can be go into the document and it can search it. So the searching functionality is called as retriever. Okay, the person who is searching, right? The same way here, the mechanism which it is searching there, right? So that is called as retriever. So using that retriever, we are trying to see what is like, I am just trying to summarize this content. Okay. So it is trying to summarize this content. Right now it is giving me a summary of that particular document which is present there. Okay. And then now what I am trying to do is I am trying to do the generator. So in this generator only, we are having something called prompt template. Okay, so inside that prompt template, right? So here we are doing a multi-string operation. So in this multi-string operation, if we do, then what it will do, it will everything whatever we are passing here, right? So this will be stored as a string into this template. Okay. So with that template, you can use to pass this. So now if you pass this question and then context to the LLM, then the LLM can be easily using, then the LLM will be helping you to get us the answer likewise. Get us the formatted answer. Anyway, you will be getting the answer in the context itself. This context will be formatted along with the query to make it more human readable stuff. Okay. So now if I run this, it is just setting up this particular string into this template. And then we are getting that template and preparing this prompt template and storing it is in LLM prompt. Like this. So now my LLM prompt will be looking like this. See, my LLM prompt will be having all these things. Right. So this is the template. My template will be this one. Okay. So inside the template, I can change this query string and context string. Okay. So query string and context string, I can directly ask this, like if I ask a question, right? So that question will be stored in the prompt. Okay. That prompt will be passed to this query engine so that it will match this question. It will put this question in the template, right? So here this question is there, right? So this will be putting here, like whatever questions, what is here, if I am putting here, it will put here. And then first initially what it will do, it will simply go to that document retriever. Okay, so this is my document retriever. Query engine is nothing but my document retriever. And there it will pass it. And with that, again, it goes to the LLM. And from LLM, it will format and it will give me the answer like this. See, now it is asking me enter a question. What question we will ask? Like, let's ask some questions. Yeah, so here it is saying that it can capable of passing 1080p resolution videos, right? Let me ask like, what is the maximum resolution video can process? Likewise, if I am asking, okay, now it is going to that retriever and that retriever, see, it is saying that it only states that video generates videos in 1080p resolution, but it didn't mention that maximum resolution. Right, this is not the maximum resolution. It is saying that 1080p resolution. Okay, and I can ask like whatever questions I want from this web page, I can ask. Yeah. So
Can we ask that there is a top impact? There is no content are showing here. We have copied only this page or entire web page?
only this particular page.
Okay, okay.
Yes, because like that's what our LlamaIndex will help us to parse.
Understood.
Right. So inside that, like any question, whatever from this web page, we can, if we want, we can ask like. See, there is something called a synth ID, right? Let's ask what is synth ID. They again run, ask. Right? Synth ID is a robust. So this is designed to watermark and identify AI generated images. The same thing for watermarking and generating AI generated contents and possible safety filters, right? Let's ask who and all worked on this project. Or part of this project. So again, going and retrieving, see, including Abhishek Sharma, Adam Shiv, all these people names. These people names are coming, right? So this is how we can utilize any we can just put any web page and build a question and answer system.
Arul, above there is a images, right? So it can describe also.
No, Ravi, because like we
Well,
used a language processor stuff only, right? So
okay.
we don't have the capability to store the images in vectors. Okay, only the text in vector. We just extracted only the text.
Text only. Okay, got it.
Ah, here we parsed this, and now we have parsed everything and stored this document with only text content. This one. Each paragraph tag, it is taking out the text and it is just having this text. See whatever text we have. This one.
Similar way, we should install or process that LLM model to read the images as well. So that take.
But I don't think any vector databases support images so far. So
Okay.
there, because like companies don't want to do any querying on top of the images, right? So for that, they can directly use this DALI or some other capabilities.
No, I am asking like if I take a Confluence page and try to convert as the Chat GPT kind of thing, or
Yeah,
then that might have the graphs, right? That's why I'm asking graph thing.
those things and all will be ignored when you are converting that into a vector database.
Okay.
Only your text format, like your resolution or something, whatever you have mentioned there, right? So
Hmm.
those information, fixtures, resolutions, whatever you are mentioning, you are writing there in the conference page, right? So
Hmm.
those information only can be extracted. Whatever is represented in text, those only will be extracted and those only will be stored in the vector database.
Even it is in a table format, right? Like,
Yeah, table also it will store. Table
okay.
also, because that is also having the text only.
Mm-hmm.
If
Pie
that
chart
is an
and
image it won't decode. Pie charts it won't decode,
okay.
right? So those things and all it can.
I'm just thinking in a other way, like real time model. How can we integrate this with my existing scenario? See, I might have 100 Confluence pages, and we
Yeah,
don't what is the content in that pages, and we cannot go. So if we can build some model on top of that, or if we can build some
yeah, rack system like this. Yeah.
rack system, that will be useful.
Yeah, that's a very good use case you get. Like this question and answering system itself is there, right? So
Yes,
in this actually, this is capable of supporting multiple web pages as well. So now we have used only one way because we don't want to overburn our memory.
correct.
In yeah. So for that particular purpose only we did. Instead, like here, see this itself is a list only. So I can put comma like this. I can put whatever web pages.
Correct. Correct. Mm. Got it.
So if we do that, then that will be like a lot of web pages, and in that web pages we can query it directly.
Okay.
So now the safety part is like your web page information, like your Confluence page information, that is stored inside your memory only.
Mm.
So with that, like first whenever your query is coming in, that query is searched from here first. So now I have only the retrieved information along with that query. That one only will be sent to the model. And as like our first example, if you are running your model also locally, then you don't need to fear about you are exposing your data.
Correct. Correct.
Yeah.
So other than that, I can ask my in my organization, is there any existing model which is in our local?
Yes, correct. Yeah.
We use
That is one good question. Yeah.
that.
So your organization also should have some local models. Yeah, that also we can use.
Mm.
Like IBM is having something called Granite. So that Granite, anyway, they were running it on our own systems only. So that is not getting exposed to the public internet, right? So if something is not exposed to the public internet and if your company is using that, then better we can use that model alone, because our purpose for this LLM here is very, very simple. What our LLM is doing is it is just formatting the question and answer whatever we are asking. That's it. It is not going to generate any response out of it.
So the main thing is to pick the correct model and prepare the RAG respectively and club both.
Yes,
You
yes,
will have
yes,
your
correct, correct. Sujit. Yeah, correct. So that's how a rack system should work. And
Yeah, yes, sir. So if we'll pick the, I mean, what you can say, running instances also. Say, for example, I create a model for daily batch.
okay,
Okay. So batch will run for 1 hour, we can say.
okay.
So, so within this 1 hour, can this or by using RAG or retrieval system, so we can get a alert saying that this match is completed this much so far, like that.
Are you storing that information somewhere, Ravi?
Somewhere in the
real time fetch he's asking.
real time fetch,
Real
exactly.
time fetch and all, yeah, that is possible. Real time also you can do that.
So RAG, I mean vector
But
database need to
anyway,
be
end of the day, yeah, anyway, end of the day, that should be in your vector database. That's it.
Vector
So
database.
whatever
Oh,
we are asking, so that information should be converted it into the vector database. Then
so
only
current,
you can apply
yeah.
RAG on top.
So for example, currently we are using a SQL developer, so that can be converted to vector database. Then we can get the data like that.
So instead of doing that, so that one like natural language processing on top of SQL, that's what you are asking, right? So for
Right.
that particular thing, what we need to do is instead of putting that database into the rack, okay, don't do that. What we can do is we can put all our table information and table related descriptions like your columns, right? You have your table columns and table related informations and table names, database names, right? So those along put it in RAG, and with that what we can do is we can prepare an SQL query. When a user is asking, see, take for an example, like if a user is asking like get me the top five insurance, top five claims from today. Like this, if some user is asking, okay, for that particular question, what you can do is today is not understandable first. So your system needs to pass the date for that to this similarity search, and that similarity search will construct a query. Okay, so now you have this table information from RAG and your date, right? So your date and table information from the RAG. So the table information and your date, those two things, if you pass it to an LLM, LLM is capable of constructing a query, right? So that query, again, what you need to do, you need to use some kind of runners from the Python itself. And using that, you can push this query to the runner, and that runner will fetch the data. And again, once you get the query output, right, that query output again pass it back to the LLM, and that LLM can read and that LLM can parse this information as a natural language, and that natural language can be responded back to the user like this. So you don't, in that sense, you don't need to build the complete data in track. I already did a project over.
Okay.
Actually, I thought of adding that also in today's class, but I don't want to make this more like that. So, project university. Natural languages.
Yeah, maybe my idea is like Ravi, your RAG should be in a batch mode. It has to run for 5 minutes or 10 minutes and make
Yeah,
a
that data pipeline kind of stuff.
yes.
Yeah, exactly, exactly.
So here, this is my table, right? Okay, so this table is having something called the patients, providers, claims, diagnosis, procedures, likewise. Okay, so this table will have this sample data like this. Okay, so in that data, this is my table description. Okay, so this table description is the one which I am going to do the RAG. So whenever I am adding a new table or any changes to my particular table schema, right? So that I need to add it in this table. So this table will be fed to my rack system. So this will be converted it into vectors. Okay. So now my vector DB will have this table description, right? So with that, what I am trying to do is I need to use this PDF processor first. So this PDF processor will read this PDF and it will simply chunk it and it will be storing it in the embedding. I was using this text embedding model and now I have this embeddings, right? So here what I used was like the ChromaDB or the files, right? Same way there is one more thing called what is that quadrant? Okay. So using that quadrant, I have stored that in this. That is the storing that. Yeah, this one is getting that embedding. Okay, I was doing a lot of steps. Okay, you can go through these programs. Okay. In main.py only, I will be using everything. So suppose in case if a user is requesting something to generate and execute SQL, what it will do, it will simply generate the query using this SQL generator. Yeah, so this query will be used and then after that we will be executing that query and that query will be sent back and then the response and the query will be sent back and that answer we will be processing back and we will be showing it to the user. Executor. So this SQL executor is nothing but it's like a kind of uh, this one we are running the query. Yeah. Yeah, I didn't have Postgres installed in my machine. Otherwise, I could have showed you this example, how this is working. Okay, you can just go through this code. You can easily understand what it is. Don't go through this flowchart.py. This is nothing. But this OpenAI RAG PDF processor. PDF processor is to decode that PDF, which is present inside this data. This one. This is going to be my schemas, right? So with that schemas alone, this schema document alone, I am just with that. So now I know these columns as well as these table names, right? So with this, now this will be stored in the embeddings, vector embeddings. So when a user is asking me a question, what it will do, it will simply go to that embeddings and it will try to match that embeddings and it will throw out all the information which is related from this table, from this document. Okay, so this will be again sent back to the LLM. So now LLM, in that LLM itself, what I am asking, what I ask to LLM is construct me a query using this information like this. So that what it will do, it will simply construct a select query out of it. Okay. So now my select query will be coming and that select query again I will be pushing it to the SQL processor. So my SQL processor will simply execute that select query on the table. So now I will have the table result and then SQL query. So these two information again I will be pushing back to the LLM to reformat that as a human readable text, right? Again, that will reformat it into a natural language. That natural language will be sent to the user as response. This is how the complete cycle works. Okay, I built this from the inspiration of Swiggy Herms. Okay, there is something called Swiggy Herms. Yeah. So this paper came on 26th of July. So with this, actually, we have built a solution for IBM for our project actually. This is how it works actually. Okay, user types of prompt. This one will be sent to the Gmail, and in that it will do the query generation, and then it sends the SQL query back, SQL output, and then That output again we will be processing through the LLM, and that LLM will response.
And Arul, like in the query preparation and all will take care by the data engineer, right?
Query preparation, not like that, Prashant. Like we have this, what what we can see, like we have the schema document, right? So that schema document will contain all the tables and the columns information. Okay,
Okay.
so that schema document only was part of our RAG.
Okay.
Okay, so that is stored on the vector database. So that schema document only, not our real tables and real columns. Nothing will be stored on the Chroma database, that vector database. So what it will do, yeah, with that we will be pushing it to the LLM. So LLM will take care of generating the query. So generating SQL will be taken care by the OpenAI model or else any large language model.
Okay. And where our role will come into picture in the project, in the Gen AI?
Yeah, complete stuff we only will decide, Prashant. Until this, only the data engineers will take care up to this rack, up to this, what to see, this data preparation part. Here we saw, right? Where is the project? Yeah, up to this data preparation part. Yeah, only this information extraction part. So from here, this chunking, embedding, everything will be taken care by the AI engineer. AI engineer only will be responsible for this vector database and this entire rack system build. So data engineers will be responsible only up to this data preparation. Because data engineers don't know what is vector database. They don't work on vector databases because this is not the regular database, right? This is a numerical database. You cannot apply any select query over there. You are building a retriever on top of it, and that retriever will take care of this. So that might be similarity search, cosine similarity, BM25, all these things yesterday we saw, right? BM25, cosine similarity.
Yeah, okay, Arul.
So this one, vector databases is not known by the data engineers. Data engineers cannot maintain this thing. Only AI engineers can understand how an embedding works and how the embedding is getting stored. So data engineers will be taking care up to this part, A and B only. From C, everything will be taken care by the AI. So as our SQL also we can explain it with this diagram itself. See, this data source will be our schema document, right? So that schema document will be embedded and it will be stored in the vector database now. Now, if a user is asking any question, okay, suppose in case if he is asking any question, now this vector database will be having my schema document and it will be giving the table name and the column names, right? So the table name and column names along with the user question, it will be passed to the LLM. So now my LLM will construct a query, right? SQL query, and that SQL query will be coming back to me. But I don't want the SQL query directly coming back to me because user cannot understand an SQL query. A business analyst cannot understand an SQL query. So what the system needs to do, instead of providing a response here, it will be again executing the SQL query using the SQL executors. Okay, that also is possible with Python. You can pass a SQL query and you can execute it with the help of Python. There is a library for PostgreSQL called, is that PySQL or something, PySQGP. What is that? Just forget that.
So Arul, the vector database having a what do you call single metadata, or that depends on the model on the RAG.
It's only vectors, Sudhir. Only it's a numerical representation.
Only. Okay. Mhm. Do you have any sample vector where that will store? Vector
It's
database.
here it is storing in this folder itself. See? Same way, there is something called quadrant, QDREANT. Okay, quadrant is a vector database. Okay, so this is looking like you can use it like a kind of, you can install and you can use it inside your machine itself. Or else there is something called Postgres SQL vector, that is PG vector.
Mhm.
Okay, so this PG vector is nothing but this is also a open source vector database that also can be stored inside your machine. But that is not like you can do some questions
Very,
like that
very,
directly.
Uh,
Your natural SQL will not work.
okay, that's better.
But PG vector, I think PG vector is supporting somehow the natural vectors in this, natural vector questions. See here and all they are doing this insert into embedding. So this is how an embedding will look like. This will be in numbers only.
Mm-hmm.
So that depends on table to table and this database to database.
in the vector database, it will store only numbering, right?
Yeah, it will store only numbers percent. It won't even store any text values. It will convert
And
everything and it will store it in the numbers.
one more question, Arul, nowadays, compared to other DBs, right, Oracle and SQL Server,
Yeah,
I say like Postgres SQL is using more in the all other
market.
projects.
Yeah,
Why is any reason behind this?
because Postgres SQL is open source and people are putting a lot of money in developing Postgres SQL. Like companies can customize the SQL itself. Oracle is a proprietary stuff. You cannot buy and you cannot customize it, right?
Okay,
But here Postgres is nothing but like it's like kind of MySQL only. So you
okay,
can take it as an open source. So that itself will be helping you to reduce the licensing cost and all. And on top
mm,
of that, if you want to customize it for your own purpose, that also you can do. See, Postgres is now supporting this vector also. That is called as PG vector. PG vector is nothing but Postgres vector. So
okay.
like Postgres is upgrading its stuff because a lot of people are working on this community. Okay,
Yeah,
so
yeah, yeah.
that's how it is growing.
And more good number of options also available in the PostgreSQL,
Yes,
Arul.
correct. PG admin is there. So using that administrator, we can install Prashant. Like we cannot install Oracle just like that, right? But
Okay.
Postgres we can directly download and install. And
Yeah, I
just
did
simply
that,
go to
Arul.
yeah.
And
Postgres is useful to study
yeah,
SQL as
okay. And it's like a natural language. So for example, if you drop in table, if you, for example, I have a product table. The product table not contained in our database. So if you give some command, right, drop table if exits products. So
yeah.
that product table is having that. If not having the database, it will not throw an error. It will give some message like the
Okay.
table is not available. So
Yeah.
like it's look like a natural language.
Yeah, right. Postgres is too good actually. So
Yeah.
lot of people, lots of developers are doing that. That's why Postgres is always trending. And also it is having a rich cloud support as well. You can use Postgres in AWS.
Yeah.
AWS is also using Postgres. There also you can execute. Azure also having Postgres. Google Cloud also having Postgres. Everything, everywhere you can use Postgres in any cloud. So this is also one biggest advantage of Postgres. In Azure, I think you cannot use this DB2. This itself, you need to have a virtual machine and do all these things. It's not out of the box, it won't support. So Postgres is one such good table SQL system, and the Postgres only we have this PG vector. So PG vector, this also will be stored in the form of a database inside Postgres itself. See, that's what they are telling. Open source vector similarity search for Postgres. Okay, so this is using this nearest neighbor and cosine similarity. These are the searching methods inside the vectors. The same way we have something called this quadrant. quadrant is also now trending. Quadrant is having something called the quadrant cloud. There we can store up to 1 GB of vectors for free. So here we log in. I already have a quadrant account. See, this is free for our 1 GB cluster like this. No credit card required. That is very, very important. See, here you can store your vectors like this. So inside this, you go to this clusters. See that natural language I have used here one. That is already running. That was already running on Google Cloud. So now it got suspended. And if a cluster is running, I can use this endpoint. Okay, and they can store this, store the information. Suspended. That's. I want to reactivate it. Let's see. Don't know like whether that will reactivate or what, because I was on a free tier account. Okay. And here using this quadrant also, instead of storing it locally, using this ChromaDB or Pice, we can store this in cloud using this quadrant. Also PG Vector also having some cloud support. Right. So there also we can store our chunked vector representations. Okay, so vector is very, very important for our RAG. So whatever you do, that will be stored in whatever personal data you have, that will be stored in this vectors only. So that numerical representations can be easily understandable by LLM. And with that, you can easily get whatever information you want. Quadrant. It's showing unhealthy. So now my cluster is up. Let's see what's inside this. Inside that, I might have some document collections. So inside this collection only we can see, like how we are seeing here, right? Inside this ChromaDB folder. Same way we can see how that embeddings happen. Okay, that numerical representations. Don't know. Maybe. Just forget everything. Quadrant and that. Because I tested this when I was trying that locally. This solution again, I was trying to propagate this solution locally in my machines. That's where this solution was there. This one. The natural language is disabled, right? So if I pass a question like this, it will simply give me all the claims in natural language, not with an SQL query. It will simply generate SQL query and it will execute it. So this is what a business analyst will do, right? So the business analyst role can be replaceable with this kind of files. Yeah, so this is also one way of doing RAG. So syllabus, where are we now? So yeah, that's all for today's class, and we will see about open source world. Okay, open source world is nothing. You go to Hugging Face. Yeah. So in Hugging Face, there are n number of models, right? So you can try out these models using the spaces mostly. You go to spaces, you can see a lot of trending spaces, right? So these and all are trending for this week. Go to here and then see what people are doing, right? So people are building a voice assistant out of this. So you need a Grok API key. right? And or else you can put an audio here and you can get the transcription out of it. So these kind of things and all people are building inside files. If you go to app.py, you can see how they are doing that, right? So this is the code behind that particular application. So whatever we were seeing that, right? So that this is the code behind that. Okay, so this is how people are building stuffs. So we can go to spaces and we can see anyone's code like this, and we can try it out also. So this is the trending colors virtual rayon. You can play around with these spaces and see like if I want to change my shirt color, what it will do. Simply I'm just taking this. This is an AI generated image. Or else for this particular person, if I want to put this dress, let's see what it is doing. Right, you can run. We get this place. I don't want to. Okay, it will take a lot of time for me. This is saying that it will take me 38 seconds, right? So it will simply put this particular dress to this particular person. It should try out. See, like this. This is how it's like the result it is showing. And see, now that particular person got changed with this dress. Right? So this is also a possibility with AI.
This is very funny.
See, we changed his complete attire to a cool attire. Like, and the point is like we don't even have a pant here, and it put a pant for him like this. So this is how AI stuffs work, and you can try doing all these things from these places. So this will give you some interesting thought process, like how these things are working, and you will start doing that, right? So
This
this AI, yeah,
this AI process also more simplify the cinematography as well, right? Right.
right, Prashant.
The
Like
last few like in the older days, right? They will editing and they're doing some animation things in the manually.
yeah,
Now very quickly they are doing and they're implementing their cinematography.
yes, correct. Like even this Kalki movie we saw, right?
Yeah, yeah.
Kalki, and then like recently Goat released for Vijay, right? So there also like they have simply changed. They have simply introduced Vijaykanth also inside that.
Mhm.
Vijaykanth is the passed away actor from Tamil Nadu. So
Mhm.
that person also they have recreated with the help of AI. And people create musicians' voice. SPB is there, right? SPB Balasubramanian.
Yeah, yeah,
So
yeah.
he was one popular singer. So his voice also they have recreated using AI, and they were singing songs. They were converting the existing song sings by person into his song like this.
Mhm.
So those kind of things and all are now trending. Like in the entertainment industry, people are using AI like anything, as you said. And when this like today also we saw something called this video. We were doing question and answering on this video only, right? See how VI is creating videos, right? So if they need a shot like this, then they need to spend some money. So now these kind of capabilities will help them to generate shots without even spending a single piece. Like just they need this graphic processor and all. Like Sora is also there. Sora is still not in the market. If Sora comes in, then Sora is also is like video creator from text. And in our introduction class itself, we saw something called runway ML. So in runway ML, yesterday I have generated something. Go to this assets. Yeah, so I uploaded a cat's image. Okay, and this was my prompt. I asked it to pretend the cat to be funny and exciting keyword. Let it type the keyboard fast. Like this, I gave the prompt. I just gave this image. Okay, see the level of video. See, it's looking so surreal. They can use these kind of things for animation industry as. So this runway ML is also too good. You can try out this runway ML. Okay, so runway ML with runway ML you can generate videos, anything like. So as we start in the first class itself, for the industry, mainly for our software industry, this retrieval augmented generation is the main most important part. But for the entertainment industry, everything in AI they are utilizing like anything. As Prashant said, in cine industry they were using it. So see here there is a voice clone also. I can clone my voice and I can do. See, I can just give me a voice reference and if I type a text and it will speak it like me, like this. So these kind of things and all are also possible. They and all these things and all use something called the text to speech. Okay. OpenAI itself is having a model called the Whisper. This is one of the top trending model. This is used to do the text to speech and speech to text like this. This is one good model. Okay, this can recognize speeches and this can transcribe speeches as. Okay. Likewise, keep yourself updated on AI and this will be helping you to build your better future like this. And so far, I thought like we have made some value out of the classes. Right? Otherwise, if you are not able to understand any concepts, please let me know at any time. Okay, so that we can connect and we can solve out whatever you want. Okay.
I think not only financial sector or something, generative AI used in along medical, most of the sectors, right?
Yeah,
Nowadays.
everywhere, wherever you name any industry, generative AI is a use case, at least one use case for it.
Okay.
But end of the sessions, like Arul, at least myself, I got clarity. So we focus on Python and RAGs rather than going to
Yeah,
LLM models. And
yeah,
uh,
Sudhir. Yeah, that's correct. Yeah.
thank you for that. Yeah.
Yeah, how was the classes? Did you like the classes or I bored a lot in between?
No, they are very interesting.
Yeah, sir, very interesting. Before starting this session or training, I heard only that AI generative AI, but what exactly this generative AI, where it will be used, how it will be used under. Now at
Yeah,
least we got some at least 50% of I mean
understand. Yeah,
concepts and understanding on generative AI. The rest of the things is based on our research, practice, and interest. Yeah.
yeah, right, Ravi. Because this is a constantly evolving field, right? So unless we keep on learning, we cannot catch the trend. That's what I told. Like, see, this as we discussed in the beginning of the class, graph rag, right? So that came on just 2 months back. Suppose if I know generative AI some 1 year back, and then if I am not touching up anything, then we don't even know what's happening in the industry. So that's why I ask you to explore this Hugging Face spaces, and then follow some people in LinkedIn, right? Go to LinkedIn and try to build your interest around this area. Like a lot of people are there in LinkedIn to follow in generative AI. Just give one Gen AI, okay? Just click on this post. You can see a lot of people are talking about it, right? So you can just try to follow those people. So, See, these people are, he is typing something, right? Likewise, go to these people and try follow these people so that, see, if we are surrounded with the people, or if we are listening to someone who is always talking about the interesting topic which we are really interested, then surely we will have a chance of building that skill set. So that's why I was asking you to do all these exercises. Go to LinkedIn, okay, surround yourself with the people, or else at least daily go through this any AI related feed and all, right? So then we can keep ourselves updated. And in YouTube also watch, start watching all these AI related videos and generative AI. Just to search for generative AI, like, so that you will get a number of videos. And then just to try seeing this. I will suggest you one person I am following. Okay, there is a guy called Mervin Bryson, and his videos are too good in generative AI. I follow that guy. You go to YouTube, and here you can search for Mervin Price. Yeah. So this guy, following this guy only, I came to know that there is a graph rack like this. So like this guy is telling daily he will put at least 1 or 2 videos. See, 2 days back itself, see how many videos he's put. Daily he will put one videos like this. Yeah, at least we will come to know, okay, what's happening in the industry, what's the new tool coming in, right? So this kind of information and all we can gather from these people. This is one guy, Mervyn Bryson. And then there is one thing called AI everywhere. For AI everything, I guess. There is another channel. This channel is also too good. See, this 1 liter coder, this guy is also too good. This guy is known as Abdul Majid Raja. So he also posts a lot of videos on a daily basis. But these YouTubers are not popular. Like they were having some 81,000, 50,000, likewise kind of subscribers only. But they will put a lot of information like this. Cerebras. On that day, I was talking about Cerebras, right? By seeing these videos only, I came to know, okay, Cerebras is now coming to the market, and this is having the fastest inference. We were seeing Cerebras, Grok, right? And we were talking about Cursor, right? So these things and all are newly coming in the market. See, 10 days, 12 days back only these things and all came into the market. And we were talking about cloud artifacts and all, right? So everything, every little knowledge we are gathering from this by following people who are who we have the interest like this. So based on our interest, we can follow these people and we can get some knowledge like this. As usual, anyway, please subscribe to Data with Arul channel also. That will be useful for me. And also please be in touch. Anyway, classes only ends here. Our friendship will not. So please be in
Yeah,
touch
yeah.
so that.
That's, yeah. Thank you so much, Arul.
Yeah, thank you, Ravi.
Thank
Thank
you
you,
very
Arun.
much. Arun.
Thank you, Sudhir. Thank you, Prashant. Thank you so much.
From now, we are always disturbing you. Number of doubts.
No, not an issue, Prashant. Anytime you can pick me.
No, actually, Arul, I want to tell you something. Like
Yeah,
after your class, right?
yeah.
Uh,